Okay, and then once the exponents come down, then we're free to distribute the log 2 through the expression, the equations. Okay, so now that all the parentheses are resolved, we see that there's two terms that have x's in them. Let's move them together on the same side. Everything that does not have x's move to the other side. Factor the x out. Distribute the remaining over, and then make the calculator get you your decimal answer.
Test for the student.
Not next Friday, the Friday after that, the 19th.
How do you evaluate like total logs? You have to convert into standard form?
So you're calculating.
Yeah, the calculator is set as log base 10, so the calculator can just.
I don't see a button on my calculator that says log. Oh, it's not.
Yeah, that's it. Yeah. So if you see log, it's just base 10. I mean, we can do other bases as well, but base 10 is the easiest one to use with our calculator. Okay, all right, let's go to page 13. Okay, this is a little bit more challenging in terms of figuring out how there's a relationship here, but you see how this is a little bit like a factoring problem. Kind of reminds you a little bit of that of a factoring problem. But here's the here's what we want to do to begin this process. Let y, sorry, not equals. Let y equals to e to the 2x, or just e to the x, sorry. So this is really e to the x what? E to 2x, same thing as e to the x squared, right? It's the same thing, right? E to the x squared plus 2e to the x minus 8. So I just want to kind of show you this form. Now, if I replace e to the x with y, look at what happens here. Y squared plus 2y minus 8 equals 0. Okay. So we're going to solve an easier problem to begin with, and then we'll go back and we'll solve for x. But right now, we have an easier problem because we have a factoring problem in front of us. So we just ask ourselves, okay, let's solve for y first. And once we solve for y, then we can turn around and figure out what x is. So factor, what multiplies to be -8 and adds up to be 2. Okay, so double check. -4 times 4 times -2 is -8. 4y minus 2y is 2. Okay, so then we can solve for y. So now our ultimate goal is to solve for x. So this is only a halfway through. So now let's see if I can solve for x. Now that I have my intermediate variable solved for, so I can say e to the x is equal to 2. If I want to solve for x with this portion, I can take the natural log of both sides, bring that exponent down. That x can come down. Now that is part of a natural log expression. Now natural log of e is same thing as 1. So x equals natural log of 2. If I try -4, e to the x equals -4. So this is basically asking e raised to what number equals -4. So here's the issue. No matter what I raise a positive number to, it can never be a negative number. So if I try taking the log of both sides, I can't take natural log of -4. If you try enter natural log of -4 in the calculator, it'll give you undefined. So there's no solution here. The only solution is x is natural log of 2.
If that's that, you have to solve it. Like,
Yeah, you leave it like that. Leave it like natural log of 2. It's an exact value.
like, do you get how they come?
Yes. I will. Well, I'll accept either form. Yeah, so the reason that we're doing this process is because otherwise it's difficult to solve this problem without creating a another variable to put it into steps, right? We solve an easier version of the problem, and then we can solve the harder variable that is in play. So for number 9, it's the same idea. There is a relationship of degree 2, degree 1, and a constant. This is also a factoring problem. Now we could factor simply in this form, but I just find it easier if we use variables like x and y. That's easier to recognize than having to factor in this form. So think of e to the 2x as y squared. Think of e to the x as y. And if we can recognize and solve an easier problem, we can go back and make that substitution. Or what we can do is we can factor, and then once we factor, we can bring back the original variable. Maybe that will feel a little bit easier. We factor, we bring back the original variable, and that way we can just solve for our problem. And we're just using that intermediate variable to help us with the factoring, but after that, we can go back to the original problem. So this is a little bit of star method here, because your A and C are, your A is not 1. So basically, you got to figure out what multiplies to be 4 times -5, which is -20, and adds it to be 8 with coefficients of 4 in play. So multiplies to be -20, adds it to be 8. Those two numbers will be 10 and -2. 10 times -2 is -20. 10 minus 2 is 8. Reduce. 10 over 4 is same thing as 5/2. -2/4 is -1/2. And I can say y plus 5/2, y minus 1/2.
We can never take the natural log of the negative.
I'm sorry?
We can never take the natural log of the negative.
That's right. Never natural log of a negative. Okay, bring the 2 out in front. We get 2y plus 5 and 2y minus 1. Okay, so maybe this is a bit easier here. Once you get through the factoring, let's bring back the original variable, and that way you can just focus your attention on solving for x. So this is 2e to the x plus 5 and 2e to the x minus 1. So we're just using that variable y to help us with the factoring to make it easier to recognize. But now we've done the factoring, bring back the original variable, and now we can just solve for each parentheses on their own. Okay, so the first one here, 2e to the x equals -5. e to the x equals -5/2. You take the natural log of both sides and you run into a problem. I can't do natural log of negative number. If you try, you'll get undefined, so there's no solution. Or actually, we can just ignore this x here. Yeah,
Do we have to show that step? Like,
you don't have to, no. 2e to the x is equal to 1. E to the x equals 1/2. Take the natural log of both sides. X is natural log of 1/2. This is the only answer that makes sense. Okay. So for the remainder of class, we're just going to do the odds. Okay, so we'll do the odds on page 13. I'll show you the steps as we go through each problem. But go ahead and start. If you want, if you feel like you need additional room, you feel free to grab a scratch sheet. Yeah, the odds. Yeah, 1 through 11. So if you look at number 1, the strategy there is find a common base, right? What's a common base that we can use for both 4 and 8? 2, yeah. So if the smaller number is not good enough for the base, then you want to shrink both numbers to be even smaller. Four can be represented as 2 squared. 8 can be represented as 2 cubed. Once the base is matched, you can remove them and then just focus on the remaining exponents that you see. Okay, number 3, 1.8 to the x equals 9.6. I can't do anything algebraically to clean it any further than that. I want to solve for x, but x is stuck in that difficult spot, in that exponent spot. What can we do to both sides to allow that x to come down? Take the what? Log of both sides, yeah. I would say log 10 or natural log, either is fine. Let's say log base 10. Once you take the log of both sides, your exponent can be free to come down. And once that exponent comes down, then everything opens up. You have division, a lot more operations that's available to you. Now it becomes x times log of 1.8. To get x by itself, just divide both sides by log of 1.8. Number 5, before you think about logs, see if you can clean things up, right? Because right now there's pieces that we can take care of before we want to involve logs. We want to involve logs when our next step is trying to get that exponent down. But before we do that, there's like terms that we can combine. There's terms that we can divide out to clean up that expression. Then we want to do that. But here we definitely want to clean up that 5 and 16 before we entertain our exponent properties for our exponent steps. now that you're sitting at e to the 2x equals 11, you can take the log or natural log of both sides. Natural log feels a little bit cleaner because it cancels out the e, but log works too. Natural log of e to the 2x equals natural log of 11. Bring the 2x down in front. Natural log of e is nice because that's equal to 1. It goes away on its own. Divide both sides by 2. There's your x.
You put, natural log in, it's like one of these calculators.
I think you'll see ln. If you see that button ln, it's right below log. On the 36 Pro, I think it's the same button. Either you tap it once or tap it twice. But if you want to test this equation with both logs and natural log, you should be able to get the same answer both ways. It's just which way you want to go. Number 7, we do need to eventually solve for x in the exponent, but there's quite a few things we should do first, right? Let's combine those like terms. Let's divide that 0.75 away from that e. We want to get that exponential expression as cleaned up as possible. Once you get it cleaned up, then you can involve natural log, or you can involve the exponent to come down. So yeah, that's fine. You can finish this up next week.
I think you like next one.
Oh yeah, so we here. These are voluntary, so I did. Mapping some reminder would be.
And 2 CACL muddy water. And 2 CACL muddy water.
Waiting topic.
Yeah,
Someday.
because
Oh.
don't
Like
like
raising off like
sediments will settle. That's a physics function.
That was bad.
Really? Oh, because
Yeah,
it does have
so-
different like size parts. But alcohol doesn't like this. This is, it just is not suspension.
I have the case under.
You put it
On
on
my website under something this one, so when I get something this next time, it's seven.
oil.
If you want, it's like this.
Mine doesn't have that. A series.
Actually,
Okay.
I'll tell you, it's an edge to me.
I'll look at the other answers and see.
It's number 7. Number 9. Same strategy as what we did at the beginning of class. The bases are hard to match, so take the log of both sides. Exponents can come down, distribute the log 9 through. Then algebraically try to get x by itself, factor that out, and divide everything over. Okay, any questions here about number 9? Okay, last one here. Number 11, this is one where we have to recognize the need for factoring. That e to the 2x, that e to the x and 6 with a constant that kind of represents that degree 2, degree 1 constants. To help you see a little bit easier, let e to the 2x be y squared, 5y and 6. You can factor that, and then you can bring back the e to the x. It's a little bit easier to see the factoring with the y's than it is with the e to the 2x. So we'll factor an easier problem, and then we'll bring back the original variable. So multiplies to be negative 36, adds up to be negative 5, is negative 94. We have to reduce with the coefficient of 6, so it's negative 3 halves and 2/3. Once you're able to get that fully factored, then you can bring back your original variable, e to the x or y. And now we can just focus our attention on solving each of the parentheses. Okay, so we set 2e to the x minus 3 equal to 0. We set 3e to the x plus 2 equal to 0. One side will give us a whole positive number, so we can take the natural log of both sides and be okay. The other side, we're going to end up with natural log of a negative number. There's no solution here, just natural log of 3 halves is our answer. Okay, Monday we'll do the evens to begin class, and then we can work out solving log equations. Okay, all right, come get your phones.
Push quiz is almost over. Push quiz, over. Like maybe 10 minutes left. That's so scary. US history? Maybe you could have. I don't know about anyone else, but maybe. I was gonna speed insult by then, if you're good at memories.